So far, we've looked at the area formulas for rectangles, squares, triangles, parallelograms, and rhombuses, and now we're going to take a look at the last type of quadrilateral that we have a unique area formula for, and that is a trapezoid. So first, what I'd like you to do, whether you know the formula or not, is take a look at this trapezoid, pause the video, and come up with some ideas about what you might do to calculate the area of this trapezoid. There are a few things we could do, but there's something that's incredibly important here. The trapezoid that you see is isosceles, but not every trapezoid is, so it's not quite as simple as simply saying, well, the distance between the two bases must be 4 meters, and those triangles are the same, because they're not necessarily. So go ahead, pause the video, see what you can do about the trapezoids, come back to see one way that you might think about it, see the area formula, and do some practice problems. So there are a number of different ways that we can think about this. Regardless of what the two non-parallel sides are, or the legs of the trapezoid, the distance between the two bases is always the same. That is 4 meters. Which means we do have this rectangle in the middle here. And we could calculate the area of the rectangle and then put these two triangles sort of together because we know that they have the same height and that they have bases that are not necessarily the same, but essentially just put these two together into a single triangle and find the area of that triangle. Now that could work on individual trapezoids, but there's not a whole lot that we can do using this method to find a formula that we can use for any old trapezoid that we see. So instead, we're going to do a little bit of a mathematical trick, and we're going to create a copy of that trapezoid, and we're going to flip it upside down. So in this case, we took the trapezoid with a 6-meter base and a 10-meter base and a 4-meter height. As we saw, we made a copy of it and flipped it upside down. And what we can do with these two trapezoids then, because they are congruent, we said we made a copy of it. These two angles are congruent. These two angles are congruent. If we rotated it rather than flipped it upside down, and we also know because the 6-meter and the 10-meter side are parallel, that these two angles are also supplementary. That means we can push the two trapezoids together in a way that because we know that those angles are supplementary because those lines are parallel, it actually extends those parallel lines into a large parallelogram like the one that we see here. And so the area formula for a parallelogram, again, is base times height. Well, the base of this parallelogram is the two bases of the trapezoid added together, and the height, of course, is the height. That's the more straightforward of the two. So to find the area of the trapezoid, we would find the area of this parallelogram and divide it by 2 because this parallelogram is made up of two identical trapezoids. So if the parallelogram area is the bases added together times height, then the area formula for a trapezoid is the bases added together times height divided by 2. So area equals 1/2 base 1 plus base 2 times height. Again, because we can create a copy of this trapezoid, turn it into a parallelogram, and then divide the parallelogram area by 1/2. So go ahead, pause the video, copy down both the diagram as well as the area formula. We'll go back and find the area of the trapezoid we saw first, and then move on to some practice problems. So if we go back to that first trapezoid, now armed with this area formula, we have 1/2 the sum of the bases, which is 6 plus 10, times the height, which is 4, all divided by 2. 6 plus 10 is 16. 16 times 4 is 64, divided by 2 is 32 square meters. Now for trapezoids, there are two particular sides that are called bases. So unlike parallelograms and rectangles and triangles, where we have the freedom to determine what's the base, what's the height, which is the length, which is the width, which side of a triangle do we want to be the base, trapezoids are specific. There are two bases and there are two legs, and they cannot be interchanged. So what you're going to do is you're going to pause the video, find the area of these 4 trapezoids that are on the screen here, come back when you are ready to see the answers and move on. One quick note, in number 4, lines that appear to be perpendicular are perpendicular, so 20 yards is the height. But go ahead, pause the video, find these areas, come back when you're ready to see the answers, and wrap the video up. So for number 1, again, remembering that our area formula is 1/2 sum of the bases times the height. What we have is 1/2, 12.5 plus 16.5, which together gives us 29. So that's 1/2 times 29 times 4, which is 58 square meters. For number 2, moving over to the right here, we have 1/2 the sum of the bases. So that's 1/2 times 14 times 10, because 10 is the height, which gives us an area of 70 square feet. In number 3, down in the bottom left, the sum of the bases, 8 plus 12 is 20. So our area formula then becomes 1/2 times 20 times 9, which gives us 90 square inches. And finally, in number 4, we have 1/2 the sum of the bases, which is 35 plus 55, or 90, times 20, which gives us an area of 900 square yards. So again, area formula of a trapezoid, 1/2 the sum of the bases times height, 1/2 b1 plus b2, all times height, because we can take a trapezoid, make a copy of it, rotate it, and turn it into a parallelogram so that the area of a single trapezoid is half of that, or half of sum of the bases times height.